Hello students, welcome to my YouTube channel and welcome to the topic of complex number. In this particular video session, just we are going to discuss about the modulus of complex number, the problems based upon modulus of complex number and some of the properties based upon complex number. Okay, so let us go through the modulus of complex number. Suppose we have taken z is equal to a plus ib be any complex number. Then the modulus of z is denoted by this symbol and it is defined as modulus of z is equal to square root of a square plus b square but with positive sign, because modulus of z can never be negative. In the complex number z is equal to a plus ib, we know that a is called as the real part of the complex number and v is called as the imaginary part of the complex number. So the modulus of the complex number is otherwise defined as modulus of z is defined as square root of the sum of square of real part of z and the square of imaginary part of z. Then let us discuss about some of the basic problems based upon modulus of complex number. Here it is the first example. Let z is equal to 3 plus 4i be any complex number. Then modulus of z is defined as then it will be 9 plus 16, then it is square root of 25 and here it is 9. Here it is 5. As all of we know that modulus of z can never be negative, so the value is 5. Another example, let z is equal to 3 minus 4i be any complex number. First of all, we have to express the given complex number in the form of a plus ib. So we have to again express this given complex number in the form of 3 plus minus 4i. Now modulus of z is equal to square root of whole square of minus 3 plus whole square of minus 4. Then again it is square root of 25 and then it is 5. And you can see that here the two modulus values are same, but the complex numbers are different. Then let us go through some of the properties based upon modulus of complex number. Before going to the properties of modulus of complex number, let us discuss about some of the remarks based upon the modulus of complex number. Now here it is the first note. In the set of complex number, the order relation is not defined. That means we cannot compare in between any two complex numbers. Suppose z1 and z2 are any two complex numbers, then we cannot establish a relation or a order relation in between z1 and z2. That means we cannot say whether z1 is less than z2 or z1 is greater than z2. So it is written that z1 less than z2 or z1 greater than z2 has no meaning. This is a invalid. Suppose let us consider z1 is equal to 2 plus 3i and z2 is equal to 3 plus 4i be any two complex numbers. Then in this case here we cannot compare between the two given complex numbers z1 and z2. That means the order relation is not defined here. Whereas note number 2 says that consider again, let us take two complex numbers are there. Suppose the first one is z1 is equal to a plus ib and z2 is equal to c plus ib. By using the formula of modulus of complex number, we can write down the modulus of z1 is equal to square root of a square plus b square, which is a real number. Again, the modulus of z2 is equal to square root of c square plus d square, again which is a real number. And in case of real numbers, we can establish a relation whether the first number is greater than the second one or the less than the second one. So hence the modulus of z1 greater than z2 or the modulus of z1 less than z2 has some meaning. Here in the case of z1, in the case of note 1, this has no meaning by using the order relation, but in case of modulus there has some meaning and it may be less than or it may be greater than. or in some cases they may be equal with each other. So here it is all about the note number 2. Let us consider another example based upon note number 2. Example, let Z1 is equal to 2 plus 3i. That implies the modulus of Z1 is equal to square root of, suppose consider it as 3 plus 4i. Then it will be square root of 3 square plus 4 square. That means it will be 5. Again, let Z2 is equal to, suppose consider it as 5 plus 12i. Then modulus of Z2, it is square root of 5 square plus 12 square. That means it will be equal to 13. So you can compare these two values. 5 is less than 13. That means modulus of Z1 is less than modulus of Z2. So modulus of Z1 less than modulus of Z2, and there is a relation between them in case of modulus, but there is no meaning in case of order relation. Then let us go through the properties of modulus of complex number. So here it is the first property. If Z be any complex number, then if modulus of Z is equal to 0, that means Z is equal to 0. Modulus of Z is equal to 0 if and only if Z is equal to 0, that is real part and imaginary part, both parts are equal to 0. So let us prove it. Let Z is equal to a plus ib be any complex number. Here real part of Z is equal to a, imaginary part of Z is equal to b. We know that modulus of Z is equal to square root of a square plus b square. It is given that, suppose we are going to prove this from left hand side to right hand side. It is given that modulus of Z is equal to 0. That implies square root of a square plus b square is again equal to 0, because we know that modulus of Z is equal to square root of a square plus b square. That implies a square plus b square is equal to 0. That implies both a is equal to 0 and b is equal to 0. The sum of two squares is equal to 0 if and only if the condition is both parts are equal to 0. That means a is equal to 0 and b is equal to 0. But we know that a is the real part and b is the imaginary part. That implies real part is 0 and imaginary part is equal to 0. So Z is equal to a plus ib. We have Z is equal to a plus ib. That implies Z is equal to, in place of a and b, we can put the value. So it is 0 plus I0. That implies Z is equal to 0. So here it has been proved. You can also prove this from the right hand side towards the left hand side. So here it is all about the property number 1. It is the first property. Then next let us go through the second property. So here it is the proof. Let us consider Z is equal to a plus ib be any complex number. We know that modulus of Z is equal to square root of a square plus b square. If Z is equal to a plus ib, then conjugate of Z, because here we have to prove that modulus of Z is equal to modulus of minus Z is equal to modulus of conjugate of Z. So it is a minus ib, and we can express it as conjugate of Z is equal to a plus I into minus b. So modulus of conjugate of Z, it is defined as again square root of a square plus b square, and consider this as equation number 2. Again, if z is equal to a plus ib, then minus z is equal to minus a minus ib, which is expressed in the form of minus a plus I into minus b. So modulus of minus z, it is again it is square root of a square plus b square, and consider this as equation number 3. So from equation 1, 2 and 3 we have, modulus of z is equal to modulus of conjugate of z is equal to modulus of minus z, negative of z. It is proved. And here it is all about the property number 2. Then let us go through the property number 3. In the property number 3, we have to prove that the multiplication of z with its conjugate is equal to the whole square of modulus of z. So let us go through the proof. Let z is equal to a plus ib be any complex number. Then z conjugate is equal to a minus ib, and modulus of z is equal to square root of a square plus b square. Left hand side, the multiplication of z with the conjugate of z, it is a plus ib multiplied with a minus ib. It is whole square of a minus whole square of ib. So it is a square minus I square b square, that implies a square plus b square. So let us go through the right hand side. Whole square of modulus of z, and modulus of z, it is square root of a square plus b square, and its whole square, it is a square plus b square. And you can see that both of the values are same. So z multiplied with its conjugate is equal to whole square of modulus of z, and it has been proved. And it is all about the property number 3. Then let us discuss about the some of the more properties of modulus of complex number. So these are the rest of the 7 properties. We have discussed about the first 3 properties of modulus of complex number, and these are the rest of the 7 properties, and you have to go for the proof of these 7 properties. So particularly in this video session, just we have discussed about the modulus of a complex number, then we have discussed about some of the problems based upon modulus of a complex number, and at last we have discussed about the 10 important properties based upon modulus of complex number. In the next video session, just we are going to discuss about some of the more problems based upon this modulus of complex number. Till then, thank you.